Question 1. Given 2 to the power of x times by 4 to the power of y is equal to 1 over 2 times under root 2. Express y as a function of x. The examiner is asking you to write y in terms of x for this equation. Starting on the left-hand side, we can write this as 2 to the power of x times by, this 4 can be written as 2 to the power of 2, with y staying on the outside, is equal to 1 over, the denominator can be written as 2 to the power of 1 times by, this under root 2 can be written as 2 to the power of 1 over 2. From here onwards, we can solve this equation by applying the laws of indices. 2 to the power of x times by, we will multiply 2 with y to get 2 to the power of 2y equal to 1 over, when the bases are same, we add the powers. So we can write this as 2 to the power of 1 plus half equals 3 over 2. As the bases are same, we can again add the powers. So we can write this as 2 to the power of x plus 2y is equal to, now here on this side, we will have to apply this law of indices, which says a to the power of negative n can be written as 1 over a to the power of n. Hence, applying this here, we can rewrite this as 2 to the power of negative 3 over 2. Hence, we can write this as x plus 2y is equal to negative 3 over 2. We can now bring the x to the right-hand side as we have to express y in terms of x. We can write this as 2y is equal to negative x negative 3 over 2. Dividing both sides by 2, we can say negative x negative 3 over 2 whole divided by 2. Now, we will divide each of these terms, which is negative 1x by 2 and negative 3 over 2 by 2, and this simplifies to negative 1 over 2x minus 3 over 2 divided by 2 is 3 over 4. And hence, this is our final answer. Question 2. The speed of small jet aircraft was measured every 5 seconds starting from the time it turned onto the runway until the time it left the ground. The results are given in the table below with time in seconds and speed in meter per second. Here is a table showing time which increases by 5 seconds, and it also shows speed of the aircraft also increasing. But the increase in speed is not proportional. In the first 5 seconds, the speed increases by 3 meters per second, and then it increases by 5 meters per second, and then it increases by 8 meters per second. So the speed of the aircraft is increasing by increasing amount for every 5 seconds on the runway. Using all of this information, estimate the length of runway used by the jet to take off. We can solve this question using Trapezium Rule. Plotting this data onto a graph with velocity on the y-axis and time on the x-axis will produce a curve which concave upwards. And in order to find the length of the runway, we have to find the area under this graph. Now this can be done either by integrating this curve, but we are not given the equation of the curve, so we can't do that. Or we can divide the area under this graph into 1, 2, 3, 4, and 5 trapezia. And we can use Trapezium Rule to work out the area under this graph. Applying the Trapezium Rule, we can say area under this graph is equal to half times by h. h is the width of each of the 5 strips, which is constant of 5 seconds. So multiply this by 5 times by, what is y0? y0 is the initial height at time 0. So this is our y0. And yn is the last value of the speed. This is our yn. And all the values in between 5, 10, 18, and 28 are values from y1, y2, y3, and y4. So putting all these values in the formula, we can say y0 being 2, yn being 42, plus 2 times all the values in between, 5, 10, 18, and 28. So area is therefore equal to half times 5 is 2.5 times by 42 plus 2 is 44 plus 2 times 61, which is the sum of all of these numbers. Area is equal to 2.5 times 44 plus 61 times 2 is 122. That will come to 166. So therefore, the area under that graph is 166 times by 2.5 is 415 meters. Question 2, part B. Given that the jet accelerated smoothly in these 25 seconds, explain whether your answer to part A is an underestimate or an overestimate of the length of runway used by the jet to take off. The length of runway was estimated using Trapezium Rule. And plotting this data on a graph with velocity on the y-axis and time on the x-axis produced a curve which was concaving upwards. The area under this curve was estimated using Trapezium Rule by dividing it into 5 trapeziums. So let's analyze one of this trapezium. We can see that the top of the trapezium, which is this line, is a straight line connecting these 2 points. And using Trapezium Rule, we work out the area below this line all the way to the bottom, whereas we were meant to work out the area under the curve. So Trapezium Rule gives us an overestimate as it includes this area. Hence, we can answer this question by saying the area under the curve, which equates to the length of the survey, is an overestimate, as the top of the trapezia, which is this line here, lies above the curve. The curve is concaving upwards and the top of the trapezia is lying above the curve. And question 3. Question 3 shows a sector OAB and the radius is 5 centimeter and the angle is 40 degrees. Figure 1 shows a sector OAB of a circle with center O, radius 5 centimeter and angle AOB to be 40 degrees. The attempt of a student to find the area of the sector is shown below. Area of the sector is equal to half r square theta, that's the formula, is equal to 1 over 2 times 5 square, 5 is the radius, times by 40, and that gives an answer of 500 centimeters square. Part A. Explain the error made by this student. It's very obvious that in this formula, the theta has to be in radians. You cannot use theta in degrees. Hence, the answer should be the value of theta has to be in radians. Part B. Write out a correct solution. The correct solution of area of a sector. So we need to first convert the theta into radians. So theta in radians would be equal to 40 degrees times by pi over 180. We always multiply degrees with pi by 180 to convert it into radians. So 0 cancels out, 2, 9 by dividing both by 2. So our final answer is 2 pi over 9 in exact form for theta in radians. Now applying the formula for the area of a sector is equal to half times 5 square times theta in radians, 2 pi by 9 is equal to 25 times 2 is 50 pi over 9 times 2 is 18. We can simplify this further. This comes out to be 25 pi over 9. We can divide both by 2 to get 25. Question 4 shows figure 2, which shows curve C1 and curve C2. And C1 and C2 are intersecting at 1, 2, 3, and 4 points. The curve C1 with parametric equations x is equal to 10 cos t, y is equal to 402 sin t, with t between 2 pi and 0. Meets or intersects curve circle 2 with equation x squared plus y squared is equal to 66. At 4 distinct points as shown in figure 2, and these are those 4 distinct points. Given that one of these points, S, which is labeled here, lies in the 4th quadrant, this is the 1st quadrant, this is the 2nd, that's the 3rd, and that's the 4th, and S lies in the 4th quadrant, find the Cartesian coordinates of S. So what does Cartesian coordinates mean? It means the x and the y value. As C1 and C2 intersect each other, that means these parametric equations must satisfy this equation as well. In other words, when we input the y value inside and the x value inside this equation, that should also equal to 66 at the point of intersection between these two curves. So we will start off by inputting the y parametric equation and the x parametric equation into this equation of C2 and solve it from there. So substituting y and x parametric equations, we get 10 cos t square plus, instead of this y, we will write down 4 under root 2 sine t bracket close square is equal to 66. Expanding this out, we can write this as 100 cos square t. This expands to 4 under root 2 square, can be written as 16 times 2, so that is 32 sine square t is equal to 66. Now we can use the identity sine squared t plus cos squared t is equal to 1. Rearranging this in terms of cos squared t, we can write this as 1 minus sine squared t. So instead of cos squared t, we can write it as 1 minus sine squared t. Writing it out, we can say cos squared t is 1 minus sine squared t plus 32 sine squared t equals 66. Let's expand these brackets out. We can write this as 100 minus 100 sine squared t plus 32 sine squared t is equal to 66. So as these are like terms, we can write this as 100 minus negative 100 plus 32 is negative 68 sine squared t equals 66. Now bring sine squared t to the right hand side and 66 to the left. So it will be 100 minus 66, that would be 34. And negative 68 to the right hand side will become 68 sine squared t. Now dividing both sides by 68, you can write this as sine squared t is equal to 34 divided by 68, which is 1 over 2. Now underrooting both sides, we can write this as sine t is equal to under root 1 over 2 plus minus. We can find the value of t by taking sine inverse of this value. So t therefore equals sine inverse under root 1 over 2, which is the plus value for this. And t can also be found by taking sine inverse of the negative value, which is negative under root 1 over 2. Inputting into this calculator will give us an answer which is 45. And for this one, we will get an answer which is negative 45 degrees. Now we can use these angles to find the point of intersection in the 4th quadrant. Now in the 4th quadrant, as you can see here, this is the 1st, 2nd, 3rd, and 4th. The point of intersection has an x coordinate which is positive and a y coordinate which is negative. So we need to make choice of the angle that we take and input into our parametric equations to get the corresponding x and y values for S. So thinking about y first, if we put 45 as a value of t, we will get a positive value for y, so which cannot be s, because s needs to have a negative value. So we will take negative 45 and input into this parametric equation to get a negative value for y. Hence, we can write this as y equals 4 under root 2 times by sine brackets with t value being 45, negative 45, sorry. And this will give you an answer, which is negative 4. Now we need a positive value for x. So which of the two t values would you input to get a positive value for x being 10 cos t? And answer is 45 degrees. And by inputting 45 into it, we will get a positive value for x. Hence, we can write this as x equals 10 cos 45. And that, inputting into your calculator, will give an answer 5 under root 2. Hence, the coordinates of point x, which is the point of intersection of two curves in the fourth quadrant, is 5 under root 2 minus 4. And these are the Cartesian coordinates of S. Question 5. Figure 3 shows a sketch of the curve with equation y is equal to square root of x. The point P, x and y value of point P, lies on the curve. So here is figure 3. It shows a curve which is y is equal to square root of x. And here is point P with its x and y value lying on the curve. The rectangle shown shaded on figure 3, this is a shaded rectangle, has a height y, which is labeled y here, and width delta x. Calculate limit of delta x when it approaches 0, sum of all the rectangles between the x values of 4 and 9, square root of x times by delta x. So what does this notation actually means? This notation means the area under the curve between the x values of 4 and 9. And alternatively, this could also be found, which is the area under the curve, by taking a definite integral of square root of x with respect to dx between the x values of 9 and 4. So student must understand, how is this area under the curve? So I'm going to first explain that why is this the area under the curve and how is that equal to that, and then solve this question from here onwards. Although we don't need to do that in exam, we just need to know and identify that this notation equals the area under the curve by taking the integral of square root of x between the x values of 4 and 9. But it is good to understand how is this area under the curve. So let's understand how are these two equations equal to each other. Here is a graph of y is equal to square root of x. We can find the area under this curve between the x values of 4 and 9 by dividing the area into 5 rectangles. Each rectangle has a width of delta x, and the height of each rectangle can be determined by inputting the x value, let's say 5, into the equation of the function, which is y is equal to square root of x. Hence, the height when x value is 5 is under root 5. So, the area of one of these 5 rectangles can be determined by multiplying the width with the height. So, we can write this as square root of x, which is the height of one of the rectangle, times by delta x. This will give us the area of one of these rectangles. But if we add the areas of all of these 5 rectangles, we will get the area under the curve. And this can be mathematically written as sum of all the rectangles from 1 to 5. So this equation denotes the sum of all the 5 rectangles, and this gives us the area under the curve. But this is not an accurate value for area under the curve between the x values 4 and 9 because some parts of the rectangles are sticking out above the curve. So we are overestimating our area. But we can get a more accurate value of this area by dividing this into greater number of rectangles. And this is the case on the right hand side, where I have divided the area under the curve between the x values of 4 and 9 into 10 rectangles. And each rectangle has a width of delta x. And the height of each rectangle can be found by inputting the x value into the function. So in this case, the area of one rectangle can be written as under root x times by delta x. That will be the area of one rectangle. And sum of all the rectangles, all the 10 rectangles in this case, can be mathematically written as I is equal to 1 to 10 rectangles between the x values of 4 and 9. So this is a notation that gives us the area under the curve for x values 4 and 9, but this is a relatively better estimate for this area as the area of the rectangle poking above the curve is much smaller than in this case. But it's still not an accurate value for the area. So what can be done to increase the accuracy of the area under the curve? We can increase the number of rectangles to infinitely large number. So and we can write this as when n approaches infinity. That is, the number of rectangles between the x values 4 and 9 approach infinity. That means delta x, which is the width of each rectangle, will become very minuscule such that it approaches 0. In that case, we can say that we will get an accurate value for the area under the curve. And this can be written mathematically as limit when delta x approaches 0 as n becomes infinitely large, the sum of all the rectangles between I is equal to 1 to n is the infinitely large number of rectangles, under root x times delta x. So this notation will give us a more accurate value for area under the curve as it reduces the amount of rectangles which are poking above the curve. And this notation is very similar to what they have written over here. Instead of writing down 1 to n, they have written between the x values of 4 and 9. So this notation or this equation gives us the area under the curve between the x values of 4 and 9, which can alternatively found by taking a definite integral of under root x for x values 9 and 4. In order to calculate the answer to this equation, we will first rewrite this as integrate between the limits of 9 and 4 square root of x with respect to dx. This can also be written as integral between 9 and 4 x to the power of 1 over 2 with respect to dx. Now, we will integrate x to the power of half, and this will be written as half plus 1, so that will become 3 over 2, divided by 3 over 2, and we will apply the limits 9 to 4. This can be further simplified to this 1 divided by 3 over 2 can be written as 2 over 3, x to the power of 3 over 2, with limits 9 and 4. First, we will input 9 into this equation. So 2 over 3, 9 to the power of 3 over 2, minus, we will now input 4 into this equation. That will be 2 over 3, brackets 4 to the power of 3 over 2. Now we will input this calculation into the calculator, which gives an answer of 38 over 3. Hence the answer is 38 over 3. Question 6. Figure 4 shows a sketch of graph of y is equal to g of x, where g of x is defined by two equations for different values of x. For x values less than equal to 2, the equation of g of x is defined by x minus 2 square plus 1. For x values greater than 2, it is defined by a straight line 4x minus 7. Looking into the graph, we can see that this is x is equal to 2. For any values of x greater than 2, the g of x is defined by a straight line, which is 4x minus 7. And for any values of x less than or equal to 2, this is defined by a curve, which is a quadratic equation with a minimum point at 2, 1. Part A. Find the value of g of 0. So this is a composite function. We will first solve the inside, which is g of 0, with x being 0. So let's solve that. G of 0. Now, which of the two equations would you take out of these two to input our value 0? We will take the first equation, as that equation is defined for x values less than or equal to 2. So we will input 0 into that equation and we will get bracket open 0 minus 2 whole bracket close 2 plus 1. And this comes out to be 5. Now 5 becomes our x value for the next function, which is g again. So g of 5 equals. Now 5 is a value which is greater than 2. So therefore this 5 will be defined by this equation. So let's input the 5 value into this. We will get 4 times 5 minus 7, which comes out to be 20 minus 7, hence it is 13. Question 6, part B. Find all the values of x for which g of x is greater than 28. So this question is asking us to find the values of x, which when substituted into function g of x, in other words into these equations, will give us a value which is greater than 28. Looking into this graph, we know that this point is 2. So for any values of x greater than 2, as the straight line is increasing, the corresponding y values are also increasing. So there will be an x value, let's say x1, that will give us a corresponding y value that will be 28. And we would know that for all the values greater than x1 will satisfy this equation, as they will have answers greater than 28. So for x values less than 2, the curve is also increasing upwards. There will be an x value, let's say x2, that will give us a corresponding y value that is also 28. So we would know for any values of x less than x2 will satisfy this equation, as the answer along this graph will always be greater than 28. So in order to solve this question, we will make these equations equal to 28 and solve for x. Starting with this equation, x minus 2, bracket close, square plus 1 equals 28. And solving for this will give us x2. So x minus 2, whole bracket square, bringing 1 to the right hand side will give us 27. Square rooting both sides, we will get x minus 2 square root plus minus under root 27. Taking negative 2 to the other side, we will have x is equal to plus minus under root 27 plus 2. So if we plug this number into the calculator, for first one I've taken positive under root 27 plus 2. That gave me a positive answer. And for second one, I took negative under root 27 plus 2. That gave me a negative answer. So which of these two answers is the true value of x? We know from this graph that the value of x2, which is defined by this curve, has to be negative. It can't be positive value, as positive value is greater than 2. And this equation is not defined for values which are greater than 2. Hence, the value of x that defines this function on this side would be x2 is less than negative under root 27 plus 2. Using your calculator, you can even simplify that, and this can come out to be x2 is less than negative 3 under root 3 plus 2. Similarly, we will now make this equation equal to 28 and solve for x. So here is 4x minus 7 is equal to 28. Bringing 7 to the other side, we will have 4x is equal to 28 plus 7, which is 35. X is therefore equal to 35 divided by 4. So which values of x will define this equation? Looking into the graph again, I told you that for any values of x greater than x1 will give you a y value which will be greater than 28. So hence the final answer would be our x1 will have to be greater than 35 over 4. So our final answer must include this to be one of the x values and this to be another x value. Question 6, part C. The function h is defined by h of x equals bracket open x minus 2 bracket close square plus 1 for x values less than or equal to 2. If you look this carefully, this is actually a part of g of x. This equation written over here is exactly the same equation as that. Looking into the graph, we can see that the straight line section of this graph was represented by this equation of g of x, whereas the curved region of g of x was represented by this section. And this section is your h of x. Explain why h has an inverse but g does not. H of x, as I mentioned, is this curved region of the graph for x values less than 2. We can see that for any x values less than 2, there is a corresponding value of y. Hence, this section of the graph is a one-to-one function. And one-to-one functions have an inverse. Looking g of x as a whole, that includes the straight line section and the curved section, we can see that a value y, for example this one, will have two corresponding values of x. So this becomes a many-to-one function, and many-to-one functions do not have an inverse. So its answer can be written as h of x is a one-to-one function, so it has an inverse. G of x is many-to-one function, so therefore it does not have an inverse. Question 6, part D. Solve the equation h inverse of x equals 1 over 2. The h inverse on this side can be moved to the other side and can be written as h of negative half. So we can write this as x is equal to h of negative half. So we will input the value of negative half into this function and get an answer for x. So therefore, x is equal to brackets negative 1 over 2 minus 2 bracket close square plus 1. We can now solve this equation by inputting this value into the calculator, and we get an answer of 29 over 4 on the calculator. So hence x equals 29 over 4 as our final answer, or 7.25 in decimals. Question 7. A small factory makes bars of soap. On any day, the total cost to the factory, donated by a variable y pounds, of making x bars of soap is modeled to the sum of two separate elements. In other words, the cost to the factory, y pounds, for making x bars of soap is made up of two of these elements, which is a fixed cost and a cost that is proportional to the number of bars of soap that are made that day. Part A. Write down a journal equation linking y with x for this model. So let's define the variables and constant in this question. The total cost to the factory, which is y pounds. The number of bars of soap is donated by variable x. Fixed cost can be donated by any letter, but we can call it C. And the cost that is proportional to the number of bars, or cost per bar of a soap, can be donated by any constant, let's say k. So this question, which asks for an equation linking y with x, in other words is asking us what is the total cost to the factory for making x bars of soap. So we can find an equation for total cost of the factory, which will be y equals the cost per bar of a soap is k and total number of bars is x. So we can say k times x plus c, c being the fixed cost. The bars of soap are sold for £2 each. On a day when 800 bars of soap are made and sold, the factory makes a profit of £500. On a day when 300 bars of soap are made and sold, the factory makes a loss of £80. Using the above information, show that y equals 0.84x plus 428. In part A, we found an equation of y in terms of x, which was y equals kx plus c, where y was the cost to the factory of making X bars of soap, and K was the cost per bar of a single soap, and C was the fixed cost of making X bars of soap. And if you compare this equation with the equation that the examiner wants you to find, you can easily see that the examiner wants to know the value of K to be determined as 0.84, and he wants you to find the value of C to be 428 using the information given in the question. So let's start our answer by first understanding what is profit. The profit is determined by subtracting the revenue, which is the total income, minus the cost, gives you the profit. So what is the revenue that you obtain by selling 800 bars of soap? That would be 800 times by 2 pounds, which is the price at which each bar of soap was sold. So we can say 800 times 2, we can put this in brackets, minus the cost. And cost can be figured out using this equation. So using this question, what was X? X was 800 bars of soap. So we can say K, we don't know what is the cost per bar of soap. So K times by 800 plus C. We don't know what is the fixed cost of soap either. But we do know that revenue minus the cost would give us a profit which will be £500 as seen here. We can simplify that a little. We can say 1600 minus 800K plus C, bracket close, equals 500. Simplifying this further, we can bring this whole term on the right hand side and 500 to the left. And we can write this as 1600 minus 500 equals, this whole thing on the other side will become plus. So therefore we can write down as 800K plus C. 1600 minus 500 is 1100. Hence 1100 equals 800K plus C. So same formula can be applied to 300 bars of soap. So we can say revenue minus cost is equal to profit. So what's the revenue of selling 300 bars of soap? 300 times 2. So we can say 300 times 2 is the total revenue minus, so what is the cost? It will be 300 because X is now 300 times K. So we can write this as 300K plus C is equal to, now we didn't make a profit, we made a loss. So therefore we have to write it as negative 80. Simplifying this, we would get 600 minus brackets 300K plus C, bracket close, equals negative 80. Now we can bring negative 80 to the left hand side and this whole brackets with a negative sign to the right. So 600 plus 80 would make it 680 equals, and this going on the other side will become 300K plus C. Now in order to find the value of K and the value of C, this equation and this equation can be solved simultaneously by the process of elimination. So writing these equations down here, we can subtract the top equation from the bottom equation. So 1100 minus 680 will give us 420 equals 800 minus 300 will give 500K, and C minus C is 0. So therefore K equals 420 divided by 500, which will come out to be K equal to 420 divided by 500 is 0.4. Now in order to find C, we can substitute this value of K into either of these two equations. So let's substitute this into the first equation. We can write this down as 1100 is equal to 800 times by 0.84 plus C. 800 times by 0.84 is 672. So we will say 1100 take away 672 is equal to C. And C therefore comes out to be 428. Hence, we can finally write our answer as y equals k being 0.84, so 0.84x plus 428. Question 7, Part C. With reference to the model, interpret the significance of the value 0.84 in the equation. So what does this value 0.84 means? We have defined this as K, and K was cost per extra bar of soap made. Hence, our answer to Part C is 0.84 is the cost of each extra bar of soap made by the factory. Part D. Assuming that each bar of soap is sold on the day it is made, find the number of bars of soap that must be made on any given day for the factory to make a profit that day. In other words, what is the minimum number of soap bars that need to be sold in order for the revenue to equal the cost? So solving Part D, we can say let the number of bars of soap made/sold on a day is n. So what is the revenue when these many bars are sold? That will be equal to 2, which is the price of 1 bar, times by n. N is the number of bars. So that is the total revenue, and that must equal the cost. So the cost will be 0.84 times by n. N is the number of bars sold, plus 428. Let's bring 0.84 to the left-hand side. So 2n minus 0.84 is 1.16n equals 428. Dividing both sides by 1.16, we will get 428 divided by 1.16 would give an answer 368.96. So let's write this as 368.97. Now, if you look at the question, they're asking for the least number of bars of soap to make a profit. So we will go to the next whole number because that will give us n is equal to 369 bars that need to be made in order to just make a profit on that day. Question 8, Part 1. Find the value of 20 times by half to the power of r, and we are going to take sum of all the terms where r can take values from 4 to infinity. So we can start our answer by writing down the first 2 or 3 terms of this sequence. The first term of the sequence will be 20 times by half to the power of 4 plus second term will be 20 times by half to the power of 5. Third term would be 20 times by half to the power of 6, and so on, up to infinity. We can factorize this equation by taking 20 on the outside, and we can write down all the other terms in square brackets. So half to the power of 4 plus half to the power of 5 plus half to the power of 6, and so on. It continues up to infinity. The term inside the square brackets form a geometric sequence. A geometric sequence is, for example, like 2, 4, 8 is a geometric sequence where each term, when multiplied by a number, in this case 2, gets you to the second term. And the second term you can multiply by the same number, which is 2, to get to the third term. So in this case, the number half to the power of 4 can be multiplied by half to get you to the second number. And second number can be multiplied by half again to get you to the third number. Hence, the term inside the brackets form a geometric sequence. And the sum of all of these terms can be found by the formula of sum to infinity, which equals a divided by 1 minus r. So what is a? A is the first term of this geometric sequence, which in this case is half to the power of 4. That is our first term. Whereas R stands for common ratio. In other words, the multiple with which you will multiply the first term in order to get the second term, and which stays constant throughout this sequence. In this case, it is half. Students must remember that this formula of sum to infinity is only applicable when R is between 1 and -1. In this case, we had R value of 0.5, so we could use this formula to find sum to infinity of all these terms. So applying this formula, we will have 20 brackets open. A is half to the power of 4 divided by 1 minus R, 1 minus half. We can plug this value into the calculator and we will get our answer to be 20 times by 0.125. And 20 times by 0.125 is 2.5 as our final answer. Question 8, part 2. Show that log to the base 5 of n plus 2 over n plus 1, where n can take any values between 1 and 48, and if we sum all those terms, the answer will come out to be 2. We can start our answer by substituting n is equal to 1 into this equation. So we can write this as log to the base 5. When n is 1, 1 plus 2 is 3, and the denominator is n plus 1, so 1 plus 1 will be 2. Now substituting 2 for n, we will get 2 plus 2, which is 4, and 2 plus 1, which is 3. Now we can substitute n is equal to 3, which is log to the base 5, bracket, 3 plus 2 is 5, and 3 plus 1 is 4. And we can continue this up until n is equal to 48. I'm not going to write down all those terms, but I'm going to write down the last term, which will be log to the base 5, brackets, 50, which is 48 plus 2, and 48 plus 1 is 49. Now we can apply the law of logarithms, whereby if two logs with the same basis are adding together, we can multiply these terms. So we can write this as log to the base 5, 3 over 2, times by 4 over 3, times by 5 over 4, times by ... until the last term, which is 50 over 49. Looking into the terms here, we can see that this 3 will cancel with this 3. This 4 will cancel with this 4. And now we can see the pattern here, that this 5 will cancel with the 5 over here. And this will continue until the 49 here will cancel with the 49 here. And at the end, you'll be left with 50 from the last term and 2 from the first term. Hence, we can write this as log to the base 5, brackets, 50 over 2. This simplifies further to log to the base 5, which is 25 now, 50 over 2. And 25 can be written as log to the base 5, 5 square. 2 can go in front, so this is written as log to the base 5, 5. And log to the base 5 and 5 is 1. Hence 2 times 1, 2 is your final answer, which is what we wanted to prove for this equation. Question 9. A research engineer is testing the effectiveness of a braking system of a car when it is driven in wet conditions. The engineer measures and records the braking distance measured in meters, which is d meters, when the brakes are applied from a speed of v kilometers per hour. The graphs of d against v, which is figure 5, and log to the base 10d against log to the base 10v were plotted, and this is figure 6. Part A. Explain how figure 6 would lead the engineer to believe that the braking system should be modeled by the formula d equals k times v to the power of n, where k and n are constants, with k approximately equals 0.017. Looking into figure 5, we can see that as the velocity of the car increases, the braking distance also increases and curve is moving upwards. There is a point along the curve which is 30-20. This point means that when the speed of the car is 30, the distance required for the car to stop is 20 meters. Taking log of the velocity values and the distance values will give you a graph in figure 6 that shows a straight line with a y-intercept at 0, negative 1.77. An examiner is asking you to prove how the braking distance, which is d, can be modeled by this formula and find the value of k to be approximately 0.017. We can start our answer by taking log of the left and the right hand side of this equation, and then proving that the resulting equation matches the equation of a straight line, which is y is equal to mx plus c. So taking logs, we can say log to the base 10 of d equals log to the base 10 of k v to n. Now to the right hand side, we can apply this law of logarithms, which says log to the base 10 ab, in other words a times b, equals log to the base 10a plus log to the base 10b. Applying this to this side, we can write this as log to the base 10d equals, this will be written as log to the base 10k plus log to the base 10 v to the power of n. Now to this logarithm terms, we can apply the power rule. Power rule states that log to the base 10 a to the power of n can be written as n in front, n times by log to the base 10a. So writing this here, we can say log to the base 10 d equals log to the base 10 k plus n times by log to the base 10 v. Now we will equate this equation to the equation of a straight line, which is y is equal to mx plus c. So we can write this as our y. Log to the base 10v is our x. And on figure 6, they have plotted log to the base 10d, which is my y value. And along the x values, they plotted log to the base 10v. And that gave us a straight line. And equating this equation to a straight line, we can say that this is the gradient m. So m equals n plus c. C is the y-intercept. And in our case, log to the base 10k equals c. Looking into the graph, the c value was negative 1.77. So in order to calculate the value of k to be 0.017, we can equate the c, which is negative 1.77, to log to the base 10k. So writing on this side, I can say log to the base 10k equals c, which is negative 1.77. Now I need to find k. In order to do that, I will have to remove the logs on the left-hand side. So we can remove these logs by remembering that a to the power of n equals b can be written in logarithm terms as log to the base a to b equals n, and vice versa. So students should learn how to convert this into this form and how to remove the logs by converting this into that form. So applying the conversion from here to here on this equation, we can write this as k equals 10 to the power of negative 1.77. Putting this value into the calculator gives an answer. K is equal to 0.01692, which approximate to k is approximately equal to 0.017 up to 2 significant figures. Question 9, part B. Using the information given in figure 5, here is figure 5 that shows velocity on the x-axis and the distance traveled by the car on the y-axis. In figure 5, with k is equal to 0.017, part B, find a complete equation for the model. So that was the model. D is equal to k times v to the power of n, where k and n are constants, giving the value of n to 3 significant figures. So the examiner wants us to give this equation with the value of k and the value of n. So starting with part B, we can say D equals, now they have already given us the value of k, which is 0.017 v to the power of n. Looking at figure 5, we have a coordinate on the curve, which is 30 and 20. So the x coordinate or the v value is 30 and the d value is 20. We can substitute this value here. So d being 20, so we can write this as 20 equals 0.017 30, which is the value of v to the power of n. Now we need to find n to 3 significant figures. So we can divide both sides by 0.017. So we can write this as 30 to the power of n equals 20 divided by 0.017. So we can simplify this as 30 to the power of n equals 20 divided by 0.017 gives an answer 1176.471. Now in order to find n, we can log both sides and write this as log to the base 10 30 to the power of n equals log to the base 10 brackets 1176.471. Now, to the left-hand side, I can apply the power rule, whereby I can bring the n in front and I can write this as n times by log to the base 10 30 equals log to the base 10 1176.471. Now, in order to find n, divide both sides by log to the base 10 30. So we can write this as log to the base 10 1176.471 divided by log to the base 10 30. And this will give you a final answer of 2.0787, but writing it to 3 significant figure, our final answer will be 2.08, up to 3 significant figures. With this n value and the k value of 0.017, we can write down a complete equation for this model. So writing down the final answer, we can say D equals k value, which is 0.017 times by v to the power of n, n being 2.08. 2.08 is here, and this is your final answer for question 9 part B. Question 9 part C. Sean is driving this car at 60 kilometers per hour in wet conditions when he notices a large puddle in the road 100 meters ahead. It takes him 0.8 seconds to react before applying the brakes. Part C. Use your formula to find out if Sean will be able to stop before reaching the puddle. So the formula that we derived in part B was D equals 0.017 v to the power of 2.08. V was the velocity and d was the distance traveled by the car before it came to rest. Let's visualize this question on this line. Here is the point where Sean sees the hazard. And he does not apply the brakes immediately. Rather, it took him 0.8 seconds before he applied the brakes. And during this time, his car was traveling at 60 kilometers per hour. And the moment he applies the brakes at point B on my line, we need to determine whether he was able to stop the car before reaching the puddle. And the total distance from the point he sees the hazard to the puddle was 100 meters. So in order to determine if Sean will be able to stop before reaching the puddle, we need to know what is the distance traveled between point S to point B, and what was the distance traveled from B to the point where it stops. So I'm labeling the distance between point S and point B from the point he sees the hazards to the point he applied the brakes to be X, and the distance traveled between point B up to the point which may be beyond P or which may be before P as Y. Distance traveled equals speed times time. Now we want to find the distance X, so we'll write down X equals, what is the speed? Speed was 60 kilometers per hour, so 60 here, times by time, but the time was 0.8 seconds. In order to convert it into hours, in order to match the units of the speed, we will divide seconds by 3,600. We get 1 over 75 kilometers as our answer. So 1 over 75 kilometers. Timesing it by 1,000 will give us an answer in meters. So we can get an answer to be 40 over 3 meters. We can write this in decimals as 13.33 meters. Now we have to find the distance y, the distance from the moment the brakes were applied to the moment it came to rest. Using this formula, we can apply d is equal to 0.017, the speed with which the car was traveling, that was 60 kilometers per hour. So we can input this here, 60 to the power of 2.08. Plugging this into the calculator, we get an answer 84.92 meters as shown in the calculator. I want to remind students that in this formula, D was in meters and V was in kilometers per hour. So we didn't have to change either of these units. We just plugged in 60 kilometers per hour and we got our distance in meters. Now we will add this and this distance together to get the total distance traveled by the car before it came to rest. So the total would be 84.92 plus 13.33, which came out to be 98.25 meters. Now this was less than the 100 meter distance from the puddle, so the car will stop before reaching the puddle. So we will write a final answer for the examiner. The Sean stops before reaching the puddle. Question 10. Figure 7 shows a sketch of triangle OAB. Here is figure 7. This is point O, this is A, and this is B of the triangle OAB. Point C is such that OC vector equals 2 times OA vector. So here is our OA vector. Let's put the direction of OA vector like this. And point C is such that OC vector, a vector drawn from O to point C, is 2 times OA. Hence, it's likely that the point C is somewhere here, such that OC vector, when drawn like that, we can draw it here actually. We can draw a line all the way from here to C. This is point C. And this is our point A. And OC vector is 2 times OA according to this equation. Point M is the midpoint of AB. Now this is our AB and point M is the midpoint. So here is our point M. The straight line through C and M. So here is our point C, here is our point M, and a straight line would be drawn from C through M, and that's the straight line, cuts OB, this is the line OB, at point N. So that is the point N where the straight line CM cuts the line OB. Given that OA is equal to A, so OA is small a and OB is equal to B. OB is therefore equals B. Part A. Find CM in terms of A and B. CM is this vector, and the examiner is asking you find CM vector in terms of A and in terms of B. In order to find CM, let's make a vector triangle whereby we can say that CM vector equals CA vector plus AM vector. So writing it down, we can say CM vector equals CA vector plus AM vector. Now, do we have CA vector and AM vector in order to calculate CM vector? The answer is no. So we will have to find CA vector as well as AM vector and substitute the values here in order to calculate CM vector. So how can I find CA vector? I know O to C is 2A. Therefore, OA is A and AC is also A. So if AC is A, then CA would be negative A because you're changing the direction of the vector. Hence, CA vector is negative A. Now we come on to the AM vector. AM vector is actually half AB vector because M is the midpoint. So we can write down AM vector on the side equals half AB vector. Now, what is AB vector? Do we have AB vector? We will have to find this AB vector by saying that AB vector equals AO vector plus OB vector. Now, what is AO vector? As OA is equal to A, so AO would be negative A. And OB vector, we already know, OB is B. Hence, AB vector is B minus A. So substituting AB vector into this equation, we can get AM vector to be, so AM vector is half times AB vector, which is B minus A. So now we can substitute CA and AM vectors into this equation in order to calculate CM. So CM vector equals CA vector, which is negative A, and AM vector, which is half B minus A. So we can write this as half B minus A. Now let's multiply this half inside, and what would you get? So CM vector, negative A plus half B minus half A. Adding these two like terms now, we will get our answer to be CM vector equals negative A minus half A is negative 3 over 2A plus half B. And this is our final answer for CM vector. Question 10 part B. Show that ON vector, this is our ON vector, is equal to 2 minus 3 over 2 lambda A plus half lambda B, where lambda is a scalar constant. So in order to find ON vector, we will have to make a vector triangle in terms of ON. And one way we can find ON is by going from O to C and then C to N. So we can write this as part B, ON vector equals OC vector plus CN vector. Now, do we have OC vector? The answer is yes, because we know OC is equal to 2A and OA vector is A. So hence we can write down on the side that OC vector equals 2A. But do we have CN vector? No, we don't. We only found CM vector in our last question. But we can relate CM vector to CN vector. And we can say something like ON vector equals OC vector plus CN vector can be written as lambda times Cm vector. So the question arises why I can write Cn vector as lambda times Cm vector. If you look carefully, points C, M, and N, they are lying on the same straight line. So Cm, whatever the Cm is, times by a number will give you the whole vector Cn. So it could be, for example, if Cm vector is x, maybe 1.5x will give you the whole vector Cn. So we can write down Cm vector as a multiple to get to Cn vector. Now we will substitute the values of OC and Cm. Cm was found in the previous question, and that was Cm vector equals -3 over a plus half b. So substituting OC and Cm into this equation, we can write this as ON vector equals OC is 2a plus lambda times Cm vector is -3 over 2a plus half b. Now we will multiply out the lambda inside, and we can write this as 2a minus 3 over 2a lambda plus half b lambda. Let's bring the like terms together. Here are two terms with a in them. So therefore we can write this as brackets 2 minus 3 over 2 lambda, bracket close, a on the outside, plus half. And in order to just make it look exactly like that, we can just bring the lambda in front and write this as lambda b. So we have shown to the examiner that ON vector can be written like that. Question 10, part C. Hence, prove that ON and the ratio of this length and the length of NB is 2:1. So this length is 2 times that length, NB. So starting this answer, we can say that OB vector equals, let's say, mu times, which is another constant I'm defining. It's mu, it's a number. It could be 1, 2, 3, whatever. It's mu times ON vector. Now, we do know that OB vector is B. That is over here. OB is equal to B. B is equal to mu times ON vector, which we found in our earlier equation to be 2 minus 3 over 2 lambda a plus half lambda b. Now, thinking on this for a moment, how can I get OB vector, which is b, by multiplying ON by a number? This tells us that ON vector must have a b term, but should not have an a term. In other words, this whole constant must equal 0, because only then 0 times a would give you 0 for this, and then this term can then multiplied by mu will give you an answer which will be b. So we can say that 2 minus 3 over 2 lambda, which is the coefficient of a, must equal 0 in order to satisfy this equation. So we can say 2 minus 3 over 2 lambda must equal 0. And this will give us a lambda value that will give us a 0 answer. So hence, bringing -3 over 2 to the right hand side, we can write down this as 2 equals 3 over 2 lambda. And therefore, lambda is equal to 4 over 3. Substituting this value of lambda, which is 4 over 3, into this equation will give us ON vector equals, now this will become 0, so that is 0a, hence this becomes 0, plus half times lambda, lambda is 4 over 3, times b. So ON vector equals 2, 1, 2 cancel, this becomes 2 over 3b. What this tells us is that ON, which is this vector, is 2/3 b, and that b was OB. So hence we can write this as ON vector equals 2/3 of OB vector. So if ON is 2/3 of OB vector, then NB has to be 1/3. Hence we can write down NB vector to be equal to 1/3 OB vector. So taking the ratio now of ON and NB is therefore ON vector colon NB vector is equal to 2:1. Question 11, Part A. Figure 8 shows a sketch of curve C with equation y is equal to x to the power of x, where the values of x are greater than 0. Here is figure 8. It shows a curve C. Part A. Find by first taking logarithms the x-coordinate of the turning point of C. This C has a turning point somewhere around here, and the examiner is asking you to find the x-coordinate of this turning point. Solutions based entirely on graphical or numerical methods are not acceptable. In other words, you have to use differentiation to figure out this turning point, because we know that at the turning point of any curve, dy by dx equals 0. So we will use this principle to solve this equation. So starting with part A, first let's take the logarithms or both sides of this equation as suggested by the examiner. So it can be written as ln y equals ln x to the power of x. Now we can apply the power rule on this side. We can rewrite this as ln y equals x ln x. As we have to find the turning point of curve C, we will have to differentiate this equation. But as we have y on the left and x on the right, we will carry out implicit differentiation. So differentiating the left and right hand side with respect to dx, we can write the left hand side as 1 over y dy by dx, as it is a y term, equals, now the right hand side can be differentiated by product rule. So applying the product rule on this side, we will differentiate this term, which will be 1, and leave the other term as it is. So that will be ln x plus, now we will leave this term, the first term, as it is, and differentiate ln x, that would be 1 over x. Simplifying that further, we will get 1 over y with respect to dy by dx equals ln x plus 1. Now if we multiply the y on the other side, we can write this as dy by dx equals y times by ln x plus 1. Now this term has y on the right hand side. We can write this in terms of x by using this equation, y is equal to x to the power of x. So hence we can write this as dy by dx equals x to the power of x brackets ln x plus 1. As we know, at the turning point of a curve, dy by dx equals 0. So we can equate this equation to 0. So writing this as x to the power of x brackets ln x plus 1 equals 0. Now each of these factors can be made equal to 0, and we can try to find out x. So we can start by writing down x to the power of x equals 0. But there is no number of x which to the power of itself can give you 0. 2 to the power of 2 is 4. 1 to the power of 1 is 1. 0 to the power of 0 is 1. So therefore, this equation is undefined. Whereas equating this equal to 0, we can get a value of x. So writing down ln x plus 1 equals 0. Taking plus 1 to the other side, it becomes ln x equals -1. Now we have to remove the logs, and we know that ln is log to the base e. So we can de-learn it by saying e to the power of -1 equals x. And this is our final answer for the x-coordinate of the turning point of the curve. Question 11, part B. The point P with x-coordinate alpha and y-coordinate 2 lies on C. So suppose our alpha is here. This is the x-coordinate, which when extrapolated onto the curve will give a y value, which is 2. Part B states that show that this value of x, or this value which is alpha, lies between 1.6 and 1.5. One way of doing this would be to take these two values and one by one substitute for x into this equation and find the corresponding y value. In one case, the y value will come out to be greater than 2, and in another case, y value will come out to be less than 2. And then we can say that our alpha, which gives a y value of 2, lies in between, somewhere in between these 2 points. Starting with the answer, here is our equation: y equals x to the power of x. So when x is equal to 1.5, in other words, when alpha is equal to 1.5, y equals 1.5 to the power of 1.5 will give an answer 1.837 as shown on the calculator here. Now we can substitute x is equal to 1.6. Substituting this into the equation, we can write this as y is equal to 1.6 to the power of 1.6. And this will give you an answer of 2.121. 2.121. Now we can see that when we input 1.6, our y value is greater than 2. And when we input 1.5, our y value is less than 2. Hence, our alpha will lie somewhere in between 1.6 and 1.5. But we have to write this down for the examiner to get few marks. So we can say 1.837 is less than 2. And 2.121 is greater than 2. And we can conclude it by saying that as the curve C is continuous between 1.6 and 1.5, alpha lies between 1.5 and 1.6. Question 11, part C. A possible iteration formula that could be used in an attempt to find alpha is x is equal to 2x1 minus x. Use this formula with x1 equals 1.5. Find x to the 4 to 3 decimal places. So we can substitute x to the 1, which equals 1.5, into this equation. And we can write this as x to 1 plus 1, which equals x2, equals 2 to x1, 1 minus x1. So we can now substitute the value of x1. x1 is equal to 1.5 into this equation. And we can say that x2 equals 2 brackets 1.5 to the power of 1 minus 1.5. And the answer on the calculator would be 1.632993162. Now using this answer, which is x2, we can input this into our equation back again and find out x3. And then we can use x3 to find x4. But we can straight away do that because it's a 2-mark question. We don't need to actually show the procedure to find x3. So we can straight away just use our calculator and plug this answer into it to find x cubed, and then use the calculator again to find x4. So x3 would be equal to 2 brackets ans bracket close to the power of 1 minus second ans. So answer would be 1.466264596, 1.466264596. Now we need to find out x4. We straight away press enter again, and that will use that answer in that equation to get us our x4, which is 1.631. So we can write down our answer to 3 decimal places. Please remember it's not significant figures, as 1.673 to 3 decimal places. Question 11 part D. Describe the long-term behavior of x to the sub n. In other words, examiner is asking you how would this equation behave in the long term? And we can do this by actually continuing this iteration up to the point where we can see the behavior of this equation. So we can take the help of the calculator and continue pressing enter, 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 because we are inputting the answer back into our equation. And we keep pressing enter, 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 enter until we see a behavior. And what we see is that if we keep doing that, there comes a point where we get an answer which is 2. And if we keep pressing it enter again, then we get an answer 1. Press enter again, we get an answer 2. Press enter again, we get an answer 1. And we can try it one more time. Then again we have 2, and then again we have 1. So this is sufficient for us to give an answer to the examiner that long term, this equation or this iteration oscillates between values of 1 and 2. Hence, for part D, my answer would be that the iteration oscillates between 1 and 2. Question 12a. Prove cos 3 theta over sin theta plus sin 3 theta over cos theta is equivalent to 2 cot 2 theta. And this is for 4 marks. So we can take either sides. We can take the left or right hand side and prove it to the other side. But the left hand side looks more messier. It has more terms in it. So let's take that side and we can write this as cos 3 theta over sin theta plus sin 3 theta over cos theta. So in order to make the denominator the same, we will multiply this fraction, the numerator and the denominator, by cos theta. And we will multiply this fraction, the numerator and denominator, by sin theta. So doing so, we can write this as cos 3 theta times by cos theta over sin theta cos theta plus, now we will multiply the numerator and denominator by sin theta. So we can write this as sin 3 theta sin theta over cos theta sin theta. Now as the denominators are the same, we can add the numerators. Hence we can write this as sin theta cos theta in the denominator, and we can add the numerators as cos 3 theta cos theta plus sin 3 theta sin theta. In order to solve the numerator, we will have to recall an addition formula for cos. Cos A minus B equals cos A cos B. You take first this and then that, plus. If there is negative, then there is plus A. And we also have plus in our numerator. So plus sin A, this A over here, and sin B, and this B goes over there. Our numerator matches this part of this equation. Hence, the numerator can be written in this form. So comparing this formula with that, we can see that our A is 3 theta and our B is theta. So therefore, the numerator can be written as cos A minus B, A being 3 theta, minus B, B is theta, over sin theta cos theta. Simplifying the numerator further, cos 3 theta minus theta can be written as cos 2 theta over sin theta cos theta. Looking into the denominator, we can simplify this by using double angle formula for sine. We know sin 2 theta is equal to 2 sin theta cos theta. We can divide both sides by 2, and that will become half sine 2 theta equals sine theta cos theta. So denominator is equal to half sine 2 theta. So writing the denominator as this, we can write this as cos 2 theta over half sine. We know that 1 over half is equal to 2. And we also know that cos 2 theta over sine 2 theta is equal to cot 2 theta. So we can write on the side as cos 2 theta, cos over sine 2 theta, or in just simply cos theta over sine theta would be equal to 1 over tan theta, which will be equal to cot theta. But cos 2 theta over sine 2 theta is equal to 1 over tan 2 theta, which is equal to cot 2 theta. You don't need to write this down, but it's good to recall this information while you're actually proving the identity. So we can write down cot 2 theta over sine 2 theta equals cot 2 theta, which is equivalent to the right-hand side of the identity, and hence this is our final answer. Hence, solve for theta between 180 and 90 degrees. The equation cos 3 theta over sine theta plus sine 3 theta over cos theta is equal to 4, giving all solutions to one decimal place. If we look this equation and compare it with the one that we figured out in part A, we can see that these two equations are same. So hence we can equate this part equals to 4. Writing this down as 2 cot 2 theta is equal to 4. Now we can divide both sides by 2. We will get this as cot 2 theta equals 4 divided by 2 is 2. Now, as I mentioned in part A, cot 2 theta equals 1 over tan 2 theta. So we can substitute, instead of this, I can write this as 1 over tan 2 theta equals 2. Now I can flip both sides and I can write this as tan 2 theta equals 1 over 2. Now I have to find values of theta in between 90 and 180. So we can use a quadrant method to solve this. So this is my quadrant 1, this is my quadrant 2, that is my quadrant 3, and this is my quadrant 4. And this is where all sine, cos, tan are positive. Here you have got sine positive, and here is only tan positive. And in this quadrant, you have cos positive. And we know that tan 2 theta is equal to a positive value, which is half. So therefore, tan lies in the first quadrant and the third quadrant. So we can first take tan inverse of half to find 2 theta equals tan inverse of half gives an answer of 26.565 on the calculator. This value is actually the alpha that you obtain here and the acute angle or alpha that you obtain here. One value that 2 theta would equal to is 26.565, which corresponds to this angle theta. And the second value would be all the way to this point here, and that would be 180 plus alpha, which will be 180 plus that, giving you an answer of 206.565. Now we can divide both of our angles by 2, and theta will therefore come out to be 13.28. And when this is divided by 2, it gives you an answer of 103.3 degrees. Now, as we know, we have to give the value of theta between 180 and 90. So we will discard this answer. Theta equals 103.3 as our only answer. Question 13. A manufacturer produces a storage tank. The tank is modeled in the shape of a hollow circular cylinder. This is a hollow circular cylinder over here at one end with a hemispherical shell. and this is the hemispherical shell at the other end. As shown in figure 9, the walls of the tank are assumed to have negligible thickness. The cylinder has radius r meters, so cylinder has this radius r meter, and same is the radius for the hemisphere. And height h meters, this is the height h meters of the cylinder. And hemisphere has radius r meters as well. The volume of the tank is 6 meter cube. That means the volume of the cylinder and the volume of the hemisphere shell on the top together gives you a volume of 6 meter cube. Show that according to the model, the surface area of the tank in meters square is given by 12 over r plus 5 over 3 pi r square. In other words, the total area surrounding this figure is this, and we have to show this to be the case in part A. So we can start our answer to part A by saying that the total surface area of this figure, figure 9, is made up of 3 different elements. First is the surface area of the circular base. The base at the bottom of the cylinder, that is the first surface area that we will have to find. We will add that surface area to the curved surface area of the cylinder. Now that is the curved surface area surrounding the cylinder will be the second surface area that we will find. And third is the surface area of the hemisphere, the top bit over here. So adding these 3 areas will give us the total surface area, and that should come out to be equal to this answer. So starting this, we can say surface area, the total surface area, equals the surface area of the circular base, and the formula for that is pi r square. That's the formula of the circular base of this cylinder. Next is the surface area of the cylinder. So what is the formula for the curved surface area of the cylinder? That is 2 pi r h. And lastly, we have to add the surface area of this hemisphere. So the formula for the surface area of the sphere is 4 pi r square. So for hemisphere, this value divided by 2, which is 2 pi r square, will give us the surface area of the hemisphere. Now we can simplify this by adding the like terms 2 pi r square by pi r square. We can write this as surface area of the figure 9 is 3 pi r square plus 2 pi r h. Now if we compare this equation with the equation given in part A, we can see there is no h in their answer in part A. So somehow we have to find out h in terms of r, and so that we can substitute in this equation to get all the terms in terms of r. And we can take help of the fact that the volume of the tank is 6 meter cube. The total volume of this figure is the volume of the cylinder plus the volume of the hemisphere. So adding these two volumes together, we can say the total volume V equals pi r square h is the volume of the cylinder. The formula is volume of the cylinder equals pi r square h. And the volume of the sphere is 4 over 3 pi r cube. But as this is a hemisphere, we will divide 4 over 3 pi r cube divided by 2 to get the volume of the hemisphere. We can simplify this further. The volume we have is 6 pi r square h plus, using your calculator, we can find the value of 4 over 3 divided by 2. This will give you 2 over 3 pi r cube. Let's factorize this equation, and I'm going to bring 6 to this side and this to the left. So I can write this as pi r square brackets h plus 2/3 r bracket close equals 6. Dividing both sides by pi r square, we can write this as h plus 2/3 r equals 6 divided by pi r square. As we have to find h, we can bring 2 over 3 to the right hand side and write it as h equals 6 over pi r square minus 2/3 r. Now this value of h can be substituted into this equation, and we can write this as surface area of the whole figure equals 3 pi r square plus 2 pi r brackets 6 divided by pi r square minus 2/3 r. Now we have to solve this equation and prove that this ends up being this, which is what is shown in part A, to be the total surface area of figure 9. We can start by multiplying 2 pi r with 6 over pi r square and 2 pi r with 2 over 3 r. So surface area equals 3 pi r square plus 6 times 2 pi r can be written as 12 pi r over pi r square minus 2 times 2 is 4 pi r squared, do not forget this r, over 3. Now we can simplify it further. We can say the total surface area equals 3 pi r square. Now pi cancels with pi, r cancels with r, so we are left with plus 12 over r minus, now this stays as 4 over 3 pi r square. Now we can collect the like terms, so negative 4 over 3 pi r square and 3 pi r square. So we can say surface area is equal to 3 pi r square, and bringing this to the left hand side, we can say it's 4 over 3 pi r square plus 12 over r. Now taking the common denominators of this and this, we can then subtract them. So we can say surface area is equal to, now we can assume that this is 1. So multiplying the numerators and the denominator by 3 will give the same denominator as this term. So we can say 9 pi r square over 3 minus 4 over 3 pi r square plus 12 over r. As the denominators are same, now we can subtract the numerators. So therefore we can say surface area is equal to 9 pi r square minus 4 pi r square. It becomes 5 pi r square over 3 plus 12 over r. This is the same answers that they wanted us to prove in part A, hence this is my final answer. Question 13, part B. The manufacturer needs to minimize the surface area of the tank. Use calculus to find the radius of the tank for which the surface area is minimum. So the examiner wants us to use differentiation in order to find out the r value for which the surface area of the tank will be minimum. So we will use the principle that the maximum or minimum value of any equation can be found by differentiating it and making it equal to 0. So we can write this as A equals, which is the surface area, equals 12. Now we will have to remove the r from the denominator and write down in the numerator as r to the power of -1 plus 5 over 3, which is a constant, pi r square. Now differentiating this area with respect to r, we will write this as dA over dr. So we will take this -1 and multiply with this number, and we will get -12 r, and we will subtract -1 from the power, and we will get this as -2. This 2 will be multiplied by 5/3, so we will get this as 10/3 pi r. 2 minus 1 is 1. We will now equate this equation to 0, so the answer would be -12 r to the -2 plus 10/3 pi r is equal to 0. To solve further, we will first change this back into the fraction form. And we can write this as -12 over r square plus 10 pi r over 3 equals 0. Now, in order to remove the r square from the denominator, we will multiply each term with r square. So throughout, we will multiply each term with r square, and we will get this to be -12, whereas r squared times by 10 pi r square will become 10 pi r cube over 3 is equal to 0. Now we will bring the -12 to the other side. It will become 10 pi r cube over 3 is equal to 12. Now multiplying 12 by 3 and then dividing by 10 will give us pi r cube equals 12 times 3 divided by 10. So 12 times 3 is 36. Divided by 10 would give us this being equal to 3.6. So let me take this here further. So I can say pi r cube is equal to 3.6. So r cube equals 3.6 over pi, and cube root of that will give you r. Now we can put this value straight into the calculator and get a value for r. And the value I obtain is 1.046447736. So correct to 3 significant figure, the answer for r would be 1.05. Therefore, I can write my answer as r is equal to 1.05, correct to 3 significant figures. Question 13, part C. Calculate the minimum surface area of the tank, giving your answer to the nearest integer for 2 marks. We have already figured out in part B the radius that gives the minimum surface area for this figure. And that value of r was to exact number of figures as 1.046447736. And we can use this value substituting into the formula for the area that we figured out in part A to get the minimum surface area for this figure. So starting with C and using this value of r, I will substitute into that equation and I'll say the area or the surface area of this figure is 12 over r value, which is 1.046 ... I'll use that exact value in my calculator, plus 5/3 pi brackets 1.046 ... square. Now let's input this answer into the calculator, and I get an answer of 17.20105016. But please remember to use exact value from your part B in order to calculate this equation. And the best way to do that is actually to use the ans function on the calculator, because in this way you use the exact value from the previous part and carry it forward to the next equation. So hence my final answer is 17.201 ... But as they want the answer to the nearest integer, I'll give my final answer as 17 meters square for the minimum surface area when the r was this value. Question 14, part A. Use the substitution u is equal to 4 minus square root h to show that the integral of 1 over 4 minus square root h with respect to dh is equal to negative 8 ln 4 minus square root h minus 2 square root h plus k, where k is a constant. So this is integration by substitution equation, where we will use this substitution in order to integrate this equation and show our final answer to be this. We can start by writing down the substitution, which is u equals 4 minus square root of h. Differentiating this with respect to dh, we will get du over dh equals the differential of 4 is 0 minus this differentiated. Remember, this can be written as h to the power of half. So multiplying half in front, we will get negative half h, and we subtract 1 from the power. So this becomes negative half. So du over dh is equal to negative half h to the power of negative 1 over 2. We can move dh to the other side and write this as du equals negative 1 over 2 h to the power of negative half with respect to dh. Now we can bring all of these terms to the other side so that we can get what is dh equal to, as we need to replace dh in terms of du in this equation. So we can say dh is therefore equals du over divided by this whole term, and that will be negative half h to the power of negative 1 over 2. Simplifying it further, what is 1 divided by negative half is negative 2. This will become in the numerator as a positive, so h to the power of half in the numerator with respect to du. In other words, dh equals negative 2 h to the power of half du. Now let's write h to the half in terms of u, because later on when we substitute, then we will have all the terms in terms of u. So looking into this equation, we can bring negative h to the half to the left and u to the right. We can write this as h to the half equals 4 minus u. And we can substitute 4 minus u into this equation, and we can write down dh equals negative 2 brackets 4 minus u with respect to du. Now we have all terms in terms of u. Now we will use this substitution to integrate it with respect to du. So we can say integrate. Now dh in terms of du we have already found, so we can write this as negative 2 brackets 4 minus u du. So we have replaced dh in terms of u, but the denominator is 4 minus square root h, which we know already it equals u. So we can write the denominator as u. Now we can integrate this with respect to du, as all terms are in terms of u. So simplifying this further, we can say it's negative 8 u plus 2 u over u with respect to du. Simplifying it further, we can say negative 8u plus 2 with respect to du. Now we will integrate each term individually. We can write this as negative 8 integrate 1u with respect to du plus integrate 2 du. Integrating 1 over u is ln u. So we can write this as negative 8 ln u plus 2u plus c. Now we will convert all the u terms back into h terms in order to give our final answer as written over here. So u we already know is 4 minus square root of h. Now we will substitute this instead of u. So we can write this as negative 8 ln 4 minus h square root of h plus 2 brackets 4 minus square root of h plus c. Solving it further, we can write this as negative 8 ln 4 minus square root of h plus 4 times 2 is 8 minus 2 square root h plus c. We know c is a constant, and a constant added to 8 will give you another constant. So we can say that c plus 8, let's say we can call it any variable, but since they have called it k, I'll call it k as well. This will give us our final answer to be negative 8 ln 4 minus square root of h minus 2 root h plus k. Question 14, part B. A team of scientists is studying a species of slow-growing tree. The rate of change in height of a tree in this species is modeled by the differential equation where change in height over change in time, dh over dt, equals t to the power of 0.25 4 minus square root h divided by 20, where h is the height in meters, very important, and t is the time in years after the tree is planted. Find, according to the model, the range in heights of trees in this species. So the question is asking us what is the minimum and maximum range of the trees that can be obtained according to this differential equation. And we know that in order to find maxima or minima, the rate of change is equated to 0. So we can start our answer by saying that dh over dt equals 0 in order to find out the maximum or minima. And by equating this whole term equals 0, we can say t to the power of 0.25 brackets 4 minus square root h over 20, and that equals 0. Multiplying out 20 to the right hand side, we can simplify this to t to the power of 0.25 brackets 4 minus square root h equals 0. Now, as we want to find the height of the trees, in this case the maximum height, we will equate this term equal to 0, and we can say 4 minus square root h equals 0. Taking negative h to the other side, we can write this as 4 equals square root h. And by squaring both sides, we can get the answer of h to be 16. So this is the maximum height of the tree. So even if you have a slow growing tree, it is not going to reach it to infinity. So this is the maximum height, and we know when the tree is planted, the h is likely to be equaling 0. So we can say our final answer to be the h is less than or equal to 16, and it is greater than or equal to 0 as our final answer for part A. Question 14, part C. One of these trees is 1 meter high when it is first planted. According to the model, calculate the time this tree would take to reach a height of 12 meters, giving your answer correct with 3 significant figures, and this is for 7 marks. So the examiner wants you to find the time that it takes in years for the plant to reach a height of 12 meters according to this model as defined earlier. So therefore, we will have to integrate this differential equation and find out h in terms of t or t in terms of h, and then plug in height to be 12 meters into the resulting equation to find the corresponding time in years. So let's first separate the variables of this equation with dh on one side and dt on the other side, and then we can integrate both sides. So we can write this as dh multiplying dt to the right hand side, we can write this as t to the power of 0.25 4 minus square root of h over 20 with respect to dt. I've multiplied the dt to the right hand side. Now I will bring this term in terms of h to the left hand side, and any t terms will be left on the right hand side. So this can be moved to the left hand side by dividing this side by 4 minus square root h with respect to dh. And dividing this side by the same 4 minus square root h will cancel this out, and we will be left with t to the power of 0.25 over 20 with respect to dt. Now we will integrate both sides. So integrate the left and right hand side, the left with respect to dh and right with respect to dt. The solution to the integration of the left hand side was found in part A, and that was negative 8 ln 4 minus square root h minus 2 square root h plus k. So we can use that answer straight away and write this as negative 8 ln 4 minus square root h minus 2 square root h plus k equals, now we integrate the right hand side, so we add 1 to the power, so this can be written as t to the power of 0.25 plus 1 over 20 times by the answer of this, which is 1.25 plus c. Now simplifying this equation further, we can write the left hand side as it is, which is 8 ln 4 minus square root h minus 2 square root h. Now we can bring this constant k to the right hand side, and this constant k with another constant c will give you another constant. We can call that a. So we can say that this thing simplifies to t to the power of 1.25 over 20 times by 125 is 25. You can quickly do that on your calculator. And the constant c minus k is another constant, and we can call that capital A. Looking into the equation, we can see that we have three variables. One is h, the second one is t, and a constant. So in order to find the time in years, when the h is 12 meters, we need to have a value of a. And we can use the fact that when t was equal to 0, the height of the tree, h, was 1 meter high. So we can use these two numbers to find a. So therefore, when t is equal to 0, h is equal to 1. Substituting these values into this equation, negative 8 ln, now 4 minus square root h, as h is equal to 1, square root 1 is 1. So 4 minus 1 is 3, minus square root h is 1, 1 times 2 is 2, equals, when t is 0, 0 to the power of 1.25 is 0, and 0 divided by 25 is still 0. So 0 plus a. Therefore, constant a can be written as negative 8 ln 3 minus 2. Negative 8 ln 4 minus square root h minus 2 square root h equals t to the power of 1.25 over 25 minus, now let's input the value of a, which is negative 8 ln 3 minus 2. Now we need to find time in years when h is 12 meters. So we can input, we need to find time, that's our question mark, when h is equal to 12 meters. So inputting this 12 instead of these h, we can write this as -8 ln 4 minus square root of 12 minus 2 square root of 12 equals t to the power of 1.25 over 25 minus 8 ln 3 minus 2. Now we have to solve for t. So we can start by bringing these terms to the left-hand side. So I can write this as t to the power of 1.25 over 25 equals, now this whole thing plus that would be -8 ln 4 minus under root 12 minus 2 under root 12 plus 8 ln 3 plus 2. Now let's substitute all of this value into the calculator and get an answer for that. And here is the answer on the calculator as 8.851. So we can say t to the power of 1.25 over 25 equals 8.8512, approximately to 5 significant figures. Now we can multiply 25 on the right hand side and write this as t to the power of 1.25 equals 25 times by that would give us times 25. Enter. The answer comes out to be 221.280. Now let's take the root of this to 1.25 and we can write this as t equals the root to 221.280, and that is 1.25, gives you an answer of, so putting this into the calculator, we get an answer of 75.154. Now, as the examiner wants the answer to 3 significant figures, we can give our final answer as 75.2 years.